Okay, so in a previous lesson, we looked at something that was very similar to this page over here, where we looked at comparing numbers using greater than, less than, or equal to sign. We are now looking at including decimals because there's a little bit of a step up when it comes to including decimals. Now, in order to be able to do this lesson, you need to be quite proficient. Proficient means you need to be quite confident doing the earlier episode where we just looked at using whole numbers. Let's start at the beginning. We have 4.12 and we have 6.24. We have 4 units, 1/10 and 2 hundredths, and we have 6 units, 2 tenths and 4 hundredths. You can hear me hopefully using the th at the end to identify that these are decimal numbers. These are numbers that are less than 1. They are numbers that are used to make up a part of one whole. Now this question over here is pretty simple to do because we can utilize the strategy that we used in the last video, which was underlining the highest place value that we have, and that is the units. And it doesn't seem very large, but because we have decimal numbers, we only really need to have just the units in there. And we identify that the 6 units is obviously larger than the 4, so the crocodile is going to be, of course, like we said, eating the larger number. He's a hungry, greedy crocodile. Look at him. And if we had to use that, say this in like a number sentence way, we'd say 4.12 is less than 6.24. Well, how about the next one? 7.17 and 7.96. We underline the highest place value, and we are noticing that the 7s are in fact the same value. And that's a problem because we can't compare when our highest place values are the same value. What we can do is we can look at the number in the next highest place value, and that is the tenths. Now in the tenths, we have 1/10 and we have 9/10. Now clearly 9/10 is a larger value than 1/10. You only need one more tenth to become a whole number. So therefore 7.17 is smaller than 7.96. Now Mr. Saul, we have 5.1 and we have 4.28. So surely 4.28 should be a larger number because it has more digits.
It's got 3 digits, hasn't it?
Well, that's interesting. But if we utilize our strategy, we might be able to kind of debunk this myth that the larger the amount of digits, the higher the number. And that first criteria, which is so important, is underlining the highest place value. And that would be 5 units with the 5.1 and 4 units with the 4.28. Well, the last time I checked, 5 units is a more significant number, is a larger number than 4. And therefore, that's a myth. It doesn't exist. 4.28, just because it has 2 decimal amounts, does not make that a larger number. In actual fact, all that 4.28 does is say that it's close to the number 4.3.
So you can say 5 and a bit is greater than 4 and a bit.
Yeah, absolutely. Well done. And as Mr. Saul said, if we say in the number sentence, 5.1 is greater than 4.28. Now put that into practice again in the next calculation. We've got 3.1 and we have 3.10. Now, I don't feel like we need to use the strategy that much here because we got the same number in the units and we got the same number value in the tenths. So now we have a bit of a problem because I don't have any value in the hundredths and I've got a 0 in the hundredths here. A very important vocabulary to learn is the words place holder. Now you've definitely heard myself and Mr. Saul say this before, and that is when we identify where we need to put zeros in to be able to compare or be able to utilize a number in a more effective way. Because the number 0 does not have any value. So if we add a 0 to this number, does 3.1 get any less or any more, Mr. Saul?
It's still 3.1.
It still stays the same. But what it does help us in this case is it helps us to identify that the numbers are in fact both the same value. This number over here could be just 3.1 and this number over here could just be 3.1. in itself. So therefore, these two numbers are in fact equal to each other. Let's have a look over here. I have the number 8 and I have the number 8.00. Again, in the case of these two zeros, I'm just using placeholders to identify, well, I don't know, maybe I'm using money, as we said, because money has two placeholders. Maybe this is £8. Well, is it an £8 amount the same as 8 as just a value by itself? Well, let's put the placeholders in again. And as you can see, I'm not changing the value of that number 8 whatsoever. So 8.00 is exactly the same again as 8.00. Now I know you have a query for me using this. Where do I add the placeholders? Where do I feel like I can take away the placeholders? And I think you were talking about earlier, Mr. Saul, in that what if I had the number 8 and I had the number 8.001? I'm going to have to add another place value holder in the thousandths column. Now, what, Mr. Saul, what do those values mean now, those two zeros?
We've got 0 tenths, 0 hundredths.
Yeah.
We do have a very small 1/1000th,
Right.
like if you smash something into 1,000 pieces.
Now, I couldn't take those zeros away, could I?
You can't take them away this time, no.
Because the value of this one that you see over here would change as a result. So these zeros are very important in ensuring that that one is the correct place value. It's not a hundredth, it's not a tenth, it is in fact a thousandth, and those zeros are used to identify, to help ensure that that one is in the right place.
It's like without those zeros, that little one would just float off into space. It wouldn't be connected anymore. So
Exactly.
It needs them there.
So what I can do is I might need to add a thousandth on. This is very untidy. I might need to add a thousandth on there. Is that if I'm going to add the placeholders here, a 0 doesn't change the value of the 8. Another 0 does not change the value of the 8. Another 0 does not change the value of the 8th. I have got 0. I have got 8 units here. I have 8 units here. I have 0 tenths. I have 0 tenths. I have 0 hundredths. I have 0 hundredths. And this is where I can now do my comparisons. Because I've added that placeholder in there, it is 8 is equal to 8.000, which means that when I have 8 holes, I have 0 thousandths. But however, when I have 8.001, I have 1 thousandth, which means, therefore, that 8.001 is in fact a larger number than 8.000. 8 is a smaller number than 8.001.
So to check that, I might say 8 point nothing is less than 8 and a tiny little bit.
Very good. Yeah, well used in context there.